Hello everyone, welcome to my channel Circuitry Simplified by Dr. Shobha Nikam. Before we start this video, please subscribe to this channel, press the bell icon so that you will get notification about newly uploaded videos. In this video, I'll talk about logic families in digital electronics and their comparison, and I'll specifically compare the most commonly used logic families, and those are TTL, ECL and CMOS. So before we compare anything, we must know important performance parameters to be considered. So here, while comparing logic families, we must consider technology. See, all ICs are made up of semiconductor material only, but the basic building block of every IC is transistor. And that transistor can be bipolar junction transistor, or it can be metal oxide semiconductor field effect transistor. So which technology is used is first important performance parameter. Whether TTL transistors are, whether BJTs are used or whether MOSFETs are used. Then power dissipation or power consumption, how much power our IC consumes, our technology consumes when it is in active state or when it is in static state, how much power it consumes. Then speed and propagation delay. So it is about the time taken by a signal to propagate through a logic gate. Then next comes voltage levels, amount of voltage we must apply to our IC so that our transistors will turn on. Next is noise margin, how much noise the logic family can tolerate. So next performance parameter is noise margin. So let's compare CMOS, TTL and ECL. Very first parameter is technology. So in MOS, complementary metal oxide semiconductor, here it uses MOSFETs, and it can use P-channel MOSFETs as well as N-channel MOSFETs. Whereas in TTL and ECL, both logic families use BJTs, bipolar junction transistors. Now here, the actual thing is, here in TTL family, BJTs works in saturation mode and in cutoff mode. Whereas in ECL logic family, the transistors works in active region. So they are never completely saturated or in cutoff region. And that is why ECL's speed is highest, because transistors doesn't take any time to come out of cutoff region or to go into cutoff region, because they are not in cutoff and in saturation. They are in active region only. Then power consumption. Here, power consumption in CMOS is very low. Static power consumption is minimal. Whereas in case of TTL, power consumption is moderate. Whereas in ECL, very high power consumption. So here, power consumption is high in ECL because transistors are always in active region. So some amount of current is continuously flowing through them. Whereas in case of TTL, when they are in cutoff region, no current flows through them. So power consumption is moderate here. But here power consumption is high because transistors are continuously on. They are in active region. Speed, here speed is moderate to high for CMOS. Depends on scaling. Meaning of scaling is how much is the size of transistor. 180 nanometer technology or 90 nanometer technology, or now 5 nanometer and 3 nanometer node and 7 nanometer. So based on which technology node we use, what size of transistor we use, the speed varies. Whereas in TTL, it is moderate, and here speed is very high because there is no coming in and going, coming out of saturation or going into saturation, and same for cutoff. So speed is very high. So here you can see the best part of ECL logic family is speed is very high. Then switching speed is low compared to ECL, but it is higher than TTL. In TTL, it is moderate and it is fastest. ECL is fastest. Propagation delay is high, depends on process node. Here it is moderate, and here propagation delay is very low. Noise margin is high in case of CMOS family, whereas in TTL it is moderate and in ECL it is low. Noise margin means when we say in digital we have two logical levels, 0 and 1. So when I'm saying 1, what does it mean? It means some voltage, right? So it can be 5 volt, it can be 3.3 volt, it can be 1.2 volt, any voltage. So how much noise can be tolerated? So if I'm saying 5 volt, it is not always 5 volt. It can be 4.8, it can be 4.7, it can be 4.6, any voltage. So how much minimum voltage can be considered as logical 1? And for 0, how much maximum voltage can be considered as logical 0? That is noise margin. So here it is high for CMOS. For TTL it is moderate. But for ECL it is very low. Voltage levels, see, when we connect output of one gate to the input of another gate, they must be compatible. So for first IC, if high is 3.3, for second IC also high must be 3.3 only. It must not be 5 or it must not be 1.2. So for that we must know voltage levels. So in case of CMOS, voltage levels are typically 3.3 volt to 5 volt. Now it is 0.9 also, 1.2 also for low technology nodes. For TTL, typically 5 volt, and for ECL 0.8 volt to 1.8 volt. ECL actually works on negative voltages also. Fan out, it means how many new gates we can connect to the output of our gate. So if I have AND gate and output of my AND gate is connected to how many more gates, to the inputs of how many gates, that is fan out. So here fan out is high for CMOS. It is limited for TTL, whereas it is very high for ECL logic family. Power dissipation, it is proportional to switching activity, so low power dissipation. Proportional to frequency, it is moderate here. And constant high power due to differential operation. Temperature sensitivity is low for CMOS. It is moderate for TTL and high for ECL. Cost is low here due to low power consumption, and design is also simpler. Whereas for TTL, it is moderate. In case of ECL, it is high due to complex design and more power consumption. So application areas, the TTL ICs are used in, CMOS ICs are used in portable devices, digital circuits and battery operated devices. Whereas TTL ICs are used in general purpose logic circuits. And ECL ICs are used in high speed circuits. Examples are high frequency systems, in communications they are used. So concluding remarks are, this comparison shows that CMOS is known for its low power consumption. Another advantage of CMOS is scaling. Scaling is possible. Scaling is possible means we can come down from 180 to 90, 90 to 65, 65 to 7, any nanometer node. Then TTL for its balance between speed and power, and ECL is popular for its extremely fast switching speeds but at the cost of high power consumption. So each logic family is suited for different types of applications depending on requirements for speed, power and complexity. So it was all about comparison of three logic families, ECL, TTL and CMOS. Thank you so much for watching this video. Don't forget to like, share and subscribe. Thank you. See you in next video.